Well, thank you very much. It's a privilege to be joining you folks today. So I put together a little presentation to kind of show what we're up to here in the states. Run briefly through what the U.S. Biochar Initiative. That's what I chair these days. The biochar products and uses that are moving here in the United States and some of the North American suppliers and technologies. And pictured down at the bottom, there's Char Technologies from Canada, a relatively new company, and Earth Care. That's where I was a couple of weeks ago, carbonizing manure. That's a 4 ton per hour gasifier. But the U.S. Biochar Initiative, we organized back in 2009. We had our first conference, first biochar conference. So we've been in existence for a little over 10 years. We host conferences and workshops, demonstrations. We put out a newsletter, have a website with a learning center and directory on it. We're active on social media. And we have I've been hosting a biochar discussion group since 2006. And the purpose of that group initially was to get the conversation going in support of what was at that time the International Agrichar Initiative, which of course became IBI. And so, as the U.S. Biochar Initiative, our vision is to leave a legacy of fertile soils and sequestered carbon, raising the awareness of and increase the utilization of biochar through collaboration with organizations involved in the production, application, and research. And so, what's the potential? In the United States, our Department of Energy says we have 1 billion tons per year of biomass available of various kinds. And that would contain about 500 million tons of renewable carbon. And from that, if we recover 50% of that carbon, we could make 250 million tons of biochar, which would sequester 625 million tons of carbon dioxide equivalent. And so that would be the ecological footprint of 39 million people, or 9% of the US population in 2050, or 135 million cars. So back in 2007, Johannes Lehmann told us that we should produce renewable energy, sequester carbon, and increase soil carbon. We should take biomass and produce transport fuels, energy, co-products, chemical products, and recover half of the carbon and put it in the soil. And today, the action and the interest in the biochar community in the United States are the new carbon markets. So we have 3 companies now. Of course, there are several European companies that are taking advantage of the biochar methodology in the carbon markets in Puro and Carbon Future. But we have 3 US companies that are now participating, and more are interested in and becoming certified by either Puro or Carbon Future. There's a little question as to whether it makes economic sense or not yet. The numbers, the dollar numbers or value of biochar is about $60 a ton. It works out to, with a typical multiplier of about 2.5 to 2.8 tons of carbon dioxide equivalent per ton of biochar. It works out to about 150 US dollars per ton of char. But then there are the administrative costs, which knock that down into half. And so there's a question if these are the voluntary markets, which are pretty high value, but the regulated markets are worth only about $5 a ton of carbon. So the producers are not sure whether this is really a good thing or not. But what one of the producers told us today was that what being qualified for the and selling into the carbon markets has done is attract the attention of investors who are now interested in investing some of their schemes so that they can build up capacity and generate some capital. So that's been a good co-product or byproduct, if you will, of the carbon markets. We're also seeing plants being built. We have 3 or 4 sustainable aviation fuel plants that are being built. This one called Red Rock Biofuels on the left will actually be producing about 25,000 tons of biochar a year, and we're not sure what whether they're gonna sell it as biochar or try to sell it to a steel company as a renewable carbon. There are financial incentives or legislative incentives for both. The next picture to the left is or to the right is torrefied wood, biocarbon, and biochar, and a plant that is built to process about 80,000 tons of wood a year. That's in my state of Oregon. The plant is in commissioning, and I hope to be producing a few thousand tons of biochar at that plant so we can get it out for testing. In Canada, Arex Energy is quite active with torrefaction and fast pyrolysis to oil and biochar. And just announced Frontier Bioenergy, one of my clients, has actually announced the installation of a small production facility to make renewable hydrogen with biochar as a co-product. But today, the biggest production is high carbon fly ash recovered from boilers. These are the two large suppliers, Pacific Biochar in California and Oregon Biochar Solutions in Oregon, basically recovering carbon fraction from fly ash, cleaning it up a bit, and shipping it all over the country. Some of this char actually winds up in the East Coast, 3,000 miles away. So both of these companies are selling carbon on the international markets. If you look at the markets overall, sort of the lead market or consumer is retail, garden, landscape, turf, and horticulture, also general agriculture. Variety of products, biochar and biochar amended products are being made. Most producers are finding that selling the black stuff alone is a little difficult, but if you add it to compost, or make a biochar-based compound fertilizer or biotic soil amendments, or even granulated and liquid products, those markets are growing slowly but steadily. Environmental markets are slower, but we do see some experimentation in mine reclamation, oil field remediation. We see a number of projects with filtration, like stormwater and water treatment. A lot of interest now in what to do about the so-called PFAS or PFAS contamination of water, especially wastewater, and biochar carbonization of biosolids has become of interest. We have 3 plants now in operation and 2 that are in construction or planning or construction. The U.S. Forest Service supports the U.S. Biochar Initiative for the purpose of reforestation and reduction of hazardous fuels. Biochar is being used as growing media in nurseries, outplanting, and of course, we have this nascent market for carbon removal. And out there in development are building products, testing for animal feed, and so forth. So those are the major markets. You know, we started out 10 years ago sort of advocating biochars for their porosity, their absorption capacity, their biology, but the electrochemical properties of biochar, thanks to folks like Stephen Joseph and others, are beginning to be appreciated and gaining more prominence. As far as products, we see a lot of packaged retail products. Here are 2 companies that make basically biochar amended compost products, and they're sold. The one on the left is sold regionally. The one in the center is sold nationally. There are a number of biochar amended products. And as an example, a compost operation called Missouri Organic Recycling is making this product they call Green Frontier Compost. And you can see from the ingredients, they combine yard waste, food waste, biochar, less clay, a fungal inoculant, and a mineral supplement and wood vinegar. They charge twice as much for this biochar amended compost as they do for their standard compost. They wind up with a finished compost that's about 16% biochar by finished volume. Their market is growing. They're quite proud of it. Here's one of the testimonies from one of their customers. Obviously the results are, they're quite enthusiastic about the results. One of the benefits they find is that the more biochar they use, the more food waste they can take in. Food waste ordinarily causes odor problems, has caused real problems in compost operations, but when you add biochar, it takes the odor away and improves the composting. Here's a company called CharGrow. John Nielsen, he's been using biochar and compost for 20 years. Strong advocate of biochar and lists the familiar benefits that we see in composting. We're also seeing biochars being used as carriers for beneficial supplements. In this case, a formulated product on the left, Vital Blend, Has they call it activated biochar. It's just basically biologically activated biochar. Soil amendment product with primarily humate. And on the right, the Andersons, very large national soil amendment company, is now using biochar as a carrier for their humic acid products. Liquid products, picture here from Don Graves, his cross-slot no-till drill with a liquid form of biochar. Don sent me this picture a few years ago, but today we're seeing liquid biochar products available from 3 or 4 different suppliers, and they're being used exactly in these applications. In no-till, where acid toxicity is a problem when you inject too much urea year after year, or on the right-hand side, this is a biotic soil amendment. So it's it's biochar, and you add the biologicals and the nutrients, and this product is being sold nationally to uh, the turf business, to golf and others. Uh, we have about 40% of our farmers in the U.S. have adopted no-till drilling, and on the left, a young contractor friend is using this drill with 3 boxes, the front and the rear box, he'll use seed for overseeding pasture. And on the center box, he'll put an organic fertilizer, I think poultry litter based, with about 20% biochar, and finds a tremendous increase or improvement in germination and in growth in pasture improvement. The right-hand side, Jason Mock is another contractor in Indiana, in the center of the country, and he's been using fertilizer from the plant that I showed earlier, or soil amendment, basically a biochar that's made from dairy manure. Only about 10% of our growers have adopted strip tillage, where you're actually cultivating strips and adding ingredients into a strip that's about 6 inches wide and 30 inches on center. This particular farmer, J.R. Bollinger, started doing this about 6 years ago, 5 years ago. He's improved the quality of the corn. He uses it on both corn and soybeans, and increased his yield, increased the carbon in his soil from less than 1% to over 3.5% in 5 years. But he stopped talking about biochar to his neighbors because they're not interested. They don't adopt it. It's just something stupid and crazy that he does, and he makes money doing it. If you ask suppliers in California if who's buying the biochar and why are they buying it, and this one supplier told me, well, I don't know, but they keep on buying it. So after, in his case, 10 years, he's selling biochar amended compost, and farmers are finding that a biochar amended compost is excellent from a water holding capacity. So here's a biochar amended compost used in vineyards in California, more drought resistant. You had a couple of folks in New Zealand working with vineyards and vineyard pruning. Here's Kelpie Wilson and her, quote, ring of fire gasifier that she's developed, which is really a modified Kentucky, and she says having very good success with that. She sold about 60 of these so far for applications like this in vineyards. More other flame cap kilns are becoming of interest, particularly in forested areas where you've got what we call hand piles or small piles. On the right-hand side, this is called the Char Boss. It's an air curtain burner where you have a high velocity air blowing across the top of a box, basically, and you're removing char. This is a prototype unit that the Forest Service is testing in collaboration with a company called Air Burners. Air Burners Inc. has been selling these air burners internationally since the 1990s. The first one I used was actually in 1974, but they burn cleanly. They have relatively low char yields, but people who know what they're doing, like Steve and Joseph, have been able to get some very high yields out of a unit in Australia. The one in Australia is one of these Tiger Cat units, used to be called ROI. This is a unit we tested about 3 years ago. There are about 50 or 60 of these things in operation now. You can recover something in the order of 6% as char. And we have one contractor who's actually recovering about 25 cubic yards a day. they'll consume anywhere from 6 to 8 tons per hour. The permitting on these is actually worked out pretty well. It took us a year or 9 months actually to permit testing for a smaller unit of this, but once we did that, now permitting is much easier for people who are using them. And as you can see in the lower right-hand corner, one of these was used to recover biochar from wildfire debris. We had 1 million acres burned in the state of Oregon just last year. So we had a big fire season. And the pictures here are pictures from a test that USBI hosted about 2 years ago or 3 years ago in Oregon on juniper, one of our invasive species. Just to show you how bad our wildfire situation is, here's a graph of from the insurance companies of the number of wildfires. Last year, we had about 4.2 million hectares that were burned in 57,000 wildfires. So, and this year, the fires have already started. The Forest Service obviously sees a benefit in reducing fuels, and converting it to biochar is a good way to go. And seed balls, Australia, New Zealand, Africa, they're being used on acacia type species that will germinate readily. And Airseed Technologies, one of the companies that's been doing this. We've got a couple of companies in the US that are also using biochar as part of seed ball makeup. Just a couple of pictures of the environmental uses. Stormwater filtration, again, is interesting. We have applications in my part of the world here where they're incorporating biochar and sand in a filtration system for leachate from a log pond. And it's been in place now for about 8 years and performing very well in reducing chemical oxygen demand from the leachate. A few companies are adding 10% biochar to fiber for hydroseeding up in the upper right hand of this picture. And what they find, or what we found when we tried this about 12 years ago, was it substantially improved germination of grasses. So hydroseeding is typically used for establishing industrial lawns and closing down construction, road construction. Arborists have really picked up on biochar. We see biochar being used as an additive for in injection for increasing the porosity of soil. We see it being used, biochar amended compost being used in planting trees, establishing trees. We have Bartlett Tree Service here that uses biochar as a carrier for microorganisms in all planting all across the country. They have a couple of hundred outlets, and a friend had a large fir tree that he had Bartlett come in and work on, and he asked him. He said, "Are you using biochar in that media?" And the Bartlett guy looked around and said, "How do you know? That was supposed to be a secret." We see the Stockholm project, which you may know of the structured soil, has taken wing. Bloomberg, who funded the Stockholm project, has now put together a network of cities that are doing carbon reduction. We now have City of Boulder, City of Minneapolis, City of Cincinnati, City Park City, Utah. We've got about 6 or 7 cities that are working together on carbon reduction. Structured soils, the way Stockholm did it, are being implemented in several cities. We're also beginning to see biochar being used more now in green roofs. We have one organization that's been running around building bioreactor gardens for septic systems. The structural applications are slower to take off because permitting and so on is required. We've had people looking at the so-called CMU blocks for construction, the asphalt from our friend Van Zyl in Australia, biochar amended plastic products. The non-structural applications are likely to be the first to take off, but we really don't have any commercial production yet. What we're looking at is as a future may not be a large consumer, but the use of biochar and sodium-ion batteries and other electronic uses are of interest. And as we discussed sort of prior to talking here, we don't really pay too much attention. We don't have much respect for biochar as a feed additive in the US, but we're learning from others, learning from Australia and elsewhere. And we're kind of sneaking biochar into animal barns and appreciating the benefits without quite doing it legally yet. But we do have feeding trials underway and attempts to, the Food and Drug Administration has told us we need to demonstrate that there is a nutritional benefit to biochar and that it's not toxic, that we don't have dioxins and so on. So we have something in the order of 140, 150 producers and resellers of biochar across the United States, a large concentration in the West. Again, biochar sourced from biomass plants. And then we also have biochar emanating from the southeast, where it's a co-product of gasifiers that are used for drying timber. We have the largest producer is in the upper Midwest in Michigan. It has the capability of producing about 50,000 tons of biochar a year, but their primary market is renewable carbon for the steel industry. So rather than sequestering it in the ground, they are intent on selling it to steel producers. And in Canada, there's several steel producers that are interested in charcoal as a renewable carbon. So at the USBI, we're actually working in collaboration with the IBI and also with the Canadian and American committees, the ISO committee on an international standards for biocarbon and biochar. So we can sort out standards and methods of analysis and so on. So we're not just always talking a different language. In terms of production, biochars in the US are produced, as I said, from boilers, from gasifiers, from pyrolysis. This large boiler produces about 10 cubic yards of biochar per hour in high carbon fly ash. And as the fuel is burned in the furnace on the left, the carbon particles are suspended in the gas. They carry through the system. They're captured in a cyclone or multiclone, and that has become sort of a major source of biochar for us. And so it takes about 1.2 dry tons of biochar to produce a megawatt of electricity, and we can recover about 2% of that in the form of, biomass to produce electricity. We can recover about 2% of that incoming fuel as biochar. So we're seeing the evolution of modular systems. This RT-char, it's called, is a containerized unit. They've got 2 or 3 units out there operating. I'll be visiting one of these in California on Friday. And so we're looking forward to more of these in use. But we also see a strong push for innovative systems for working on biosolids, manures, and digestates. And on the left-hand side, there's what's now called VOW, valorizing organic waste. I think it's a VOW stands for, but they bought the BioGreen company from France, and they're heavily promoting biosolids carbonization. On the right-hand side is the Coltec or Ecoterra company, the one that I visited doing manure. They now have 11 plants operating, making biochar, 4 of them newly in Saudi Arabia in a carbonizing turkey litter, 1 in the Netherlands, 2 in Russia, and the rest in the United States. In the lower left-hand side, there's Bioforstec. They're using the Pyreg carbonizer for biosolids. They've got a couple of projects underway. As I said, there are 2 other biosolids carbonization systems. We have one that's going together in which the pyrolysis gas from the carbonizer will be going into an anaerobic digester. The digestate from the digester will be dried and carbonized. They found in a year-long trial a couple years ago that by putting the pyrolysis gas into the digester, they can increase the quality of the gas or the quantity of the gas by about 15% as well as the quality. And just to point out that that we live in an international community when it comes to biochar. Projects like this well-known project, the Rainbow Bee Eater Hollow Fresh project, have an influence, and we have a number of people looking at greenhouse applications, and I think largely stimulated by this kind of project. We're also stimulated by the simple application of biochar in developing countries. Some of you know Michael Schaefer, Dr. Michael Schaefer of Warm Heart Worldwide in Thailand, and he went to Africa, got Sister Miriam Paulette on the left-hand side excited about making biochar in pit kilns and making it from corn cobs in tea luds. And so they're feeding biochar, they're combining biochar with manure, they're getting fantastic yields in their corn crops. Their soils have almost no carbon. And so they're having really good results. And they have now trained 7,500 smallholders. And the people who are training the other smallholders are smallholders themselves who are making their own biochar. They've had such success that it's really caught fire, so to speak. And they're calling in Kenya, they're saying biochar is a farmer's best friend. So, and of course, China continues to produce biochar, and just the fact that they're producing biochar amended fertilizers in the quantities they are has a positive influence for us on our ability to promote biochar around the country. So in summary, we've got both mobile and stationary processes being developed and used. Probably the total production in the U.S. is still in that 70 to 100,000 ton per year range. The production systems are improving. We had one disaster recently where we had a company that failed, was accumulating tars and oils from their pyrolysis, and it became this week what is now called a Superfund site, and it's going to cost about $1 million to clean up. So we do have had our failures, and in the past in the U.S. we've had biochar associated with fraud. We have a couple of people spending 30 years in prison for defrauding people using kind of biochar as the poster child for their Ponzi pyramid scheme. But our markets are expanding slowly, and we're seeing better quality products. The biggest problem we have is large-scale biochar users need consistent quality, reliable delivery, and a reasonable price. And many of the small producers initially produce an inconsistent quality of char, and that's changing. People have been learning. They've figured out how to produce a consistent quality. Delivery is a problem. Biochar is light. You can't hold it very far, but as I said, some of it's going clear across the country. And then biochar is creating new market opportunities to increase value from hazardous fuels and residues. So we are using biochars to help prevent fires, and organizations like CAL FIRE in California are now spending a lot of money on mobile carbonization systems. So that's what I have to say, and I'd be happy to answer any questions.
Thank you so much, Tom. Very, very much appreciated, and a very full presentation on the topic. The air curtain story is of interest. Just recently, we've come across someone that's attempting to use basically an incinerator, but a container kind of air curtain incinerator to look at producing biochar. Not with too much success yet, but is that sort of doomed to failure, do you think?
No, actually, the air curtain burner, Air Burners Inc., and I'll send you a copy of the presentation with all of the URLs so you can access them. But the Air Burners Inc. actually has on their website instructions on how to make biochar in a standard air burner. And okay. There are a few companies that are actually commercially doing that. What it is you use the air burner like just like a Kentucky kiln or a flame cap kiln, and you keep feeding it until you fill the burner up with char, and then you let the whole batch cool down, and then dig it out and bag it or whatever you're going to do with it. But there are a few companies that are actually doing that. and one in California, which again I may be visiting this week. The other modification, of course, is the air burner with a grate in the bottom of it. That's the Tiger Cat kind of unit where you're removing it continuously. So no, it's you can use an air burner. The nice thing about the air burner is you back off the fan. Ordinarily with an air burner, you depend on the high velocity air to burn up the pollutants and burn up the smoke, and they test quite well. We actually, in running our tests, we had a certified eyeballs. We had a consultant who is certified every 6 months for measuring the pollutants opacity, and we did very well. He just sits there and observes things during 3 1-hour tests, and based on that, our air quality folks permitted other machines. So
okay, that's very interesting because yeah, no, we have some conversations to have around emissions from small contickies, but equally air curtain burners could be will be the next step, I suspect, because we have a lot of issues with wilding pine, and whether we can come up with a biochar solution to manage some of that biomass remains to be seen, but it'll be interesting anyway. Thanks, Tom.
A couple of years ago, folks in Taiwan bought an air burner, and they were having problems with their emissions people, and so I sent them test data from air curtain burners, and so their regulators gave them a permit the next day. So
very cool. Very cool.
The air burner company has been doing testing and working with our Environmental Protection Agency for more than 20 years on these things. So there's a lot of data.
Brilliant. Okay, thanks, Tom. Anyone else?
Yeah, Tom, Miles Pope, what's the price of biochar?
The price of biochar varies from the East Coast to the West, or the West Coast to the East Coast. Typically, it's between 80 at the producer. We'll sell it for $80 to $100 per cubic yard, which works out to about 40 cents a pound. It's about 250 pounds per cubic yard. Then the further east you go, the more expensive it is because there isn't as much available, and you pay high transportation costs. So instead of 80 to 100, you can spend $400, $500 a cubic yard, and in some applications, like for mercury capture, it's been sold as high as $1 a pound. So it's not cheap, and that's something I feel that farmers probably have they get interested at about $50 a cubic yard. And so what happens is that as people are recovering biochars with different qualities, that is different percentages of carbon, percentages of ash, and so on, the suppliers will sell it for a lower price and more farmers will buy it. So the reason I think most of the biochar is going into retail garden, high-end markets is really the expense. And I think that's also what's driven producers to make biochar amended products so they can add value to it. And somebody would be willing to pay $15 for 1 cubic foot bag of a biochar amended growing media.
Thank you.
Tom, Trevor here. Your high carbon boiler ash is a little different to ours. Yours is recovered from cyclones, or is it uniformly recovered that way, or do you have some bed ash, moving hearth recovery chars that are being sold as well? And what is your spec on your cyclone recovered material? How much fixed carbon is in it, and how much ash?
Well, it's really interesting, actually. The quality of the high carbon fly ash coming out of the cyclone really depends on the consistency of the fuel and the fuel preparation that goes into the boiler. But some of it is very, very consistent. And one of the suppliers told me that one of their buyers bought or tested their every truckload, and over a year and a half, and they only had a 1 or 2% variation in carbon content, and it was up around 80%. So what they're doing is taking the ash, basically the cyclone, the multiclones will capture down to about 10 microns in size. And what one of the companies does is, the one I showed the pictures of, is that they actually quench the char coming out of the cyclone and screen out the very fine fines, which screens out ash and makes a higher carbon product. We don't see very much biochar. I showed a client how to make biochar from bed ash with a reciprocating grate boiler, which they then are now combining into a soil product, but they're combining it with other materials. We generally don't see much char from the grate ash, we call it, from boilers. And typically, people want to burn out everything off the grate and then just take selectively take the higher carbon fly ash as a biochar product.
Okay, thanks.
So we have a standard in the United States. If you put biochar in a bag and put a label on it, call it biochar, you have to have a minimum of 60% carbon. That was kind of the result of some misguided stuff that happened that we actually started about 10 or 12 years ago, but we didn't really have any control over it, and it wound up being anything with a label on it says biochar, it's got to be 60% carbon. People get around that by simply saying that their product includes biocarbon, not biochar. But that's kind of a threshold number. It sort of came from originally from the IBI standard, where IBI classifies chars into 10 to 30%, 30 to 60%, and 60% in greater carbon, just as a way of classifying biochars in general. And so at any rate, yeah, the high carbon fly ash is wind up, but it's all fly ash rather than grate ash.
Okay.
Okay, well, I think one last question, if someone would like to ask it, and we've had a very good presentation. Anyone else like to have a final question? Okay, you're off the hook. And
okay.
Very much appreciated. Thank you very much.
Yeah.
Well,
Thanks,
thank you, and thank you for the opportunity to visit New Zealand.